Welcome to Study Loop.
Okay, so in this question, we want to find domain, codomains, domain of definition, and undefined for various stuffs. So for A, our function that maps the integers to the real numbers explicitly given by f of n is equal to 1 over n. Well, the domain is what we put in. So that the domain is z. Your codomain is what we get out, so the real numbers. Then your domain of definition is the domain of definition is what the function can actually accept. So in this case, because we're dividing by n, we can't divide by 0. So it will be the set of integers minus 0. And then your undefined is what we subtract away from our domain. So in this case, it will just be the set of 0. For B, our function maps integers to integers, explicitly written as f of n is equal to ceiling of n divided by 2. So the domain is what we get in, what we put in, so integers. Your codomain is what you get out, so integers. Domain of definition, because the ceiling function accepts every number, there is no restriction to it. Domain of definition is just all your integers, and your undefined, because we're not subtracting anything away from our domain, is just the empty set. Now C, f mapping integers multiplied by integers gets mapped to rational numbers, explicitly given by f of m, n, m divided by n. So our domain, what we get in, is just integers multiplied by integers. Our range, what we get out, rationals, and this is codomain. And domain of definition. Well, because we're dividing by n, n cannot be 0, but m can be whatever it wants. So m can be whatever it wants, but n cannot be 0, so it's an integers set minus 0. And then your undefined, undefined is just z multiplied by the set of 0. So what this means is that it doesn't really matter what m is. If n is 0, then we're undefined for that set. And also because if you kind of think about your algebra, this is equal to integers times by integers minus by integers set minus or times by 0. And so we're subtracting away this step. D, f maps integers times by integers to integers such that f of m n is equal to m n. Or domain, simply integers multiplied by integers. Codomain is just your integers because we're mapping into it. Our domain of definition, there is nothing, so we can multiply anything together. So this is just your domain. And your undefined, because we're not subtracting anything away from our domain, this is just empty set. Now E, f of f maps z, z cross z, f maps z cross z to z on the condition that f of m n is equal to m minus n if m is greater than n. So our domain is just what we put in, so it's integers times by integers. Codomain is just what we get out, so integers. Now our domain of definition, this is a little bit trickier because we have m must be greater than n. So if we just write this out, this is the set of integers m and n on the condition that m is an integer, n is an integer, and m is greater than n. And there is not really any way you can simplify this. So your undefined domain is then the set of m and n, where m is an integer, n is an integer, n is an integer, and the opposite of this. So that'll be m is less than or equal to n.